Good day everyone, welcome to today's tutorial. Today we're going to learn how to explore this frightening looking sum using my own techniques. So stick around and watch to the end. Don't forget to like this video. So let me name this sum S. So I have that S is equivalent to the sum. Here Q being a set of n knots means that Q starts from 0, 1, 2, 3 up to infinity. So I have here Q equal to 0, and the remaining element of this sum comes in 16 to the power of minus Q, all divided by Q plus 1 multiplying Q plus 2 multiplying Q plus 3. This is what we have here. Then next we have the binomial 2Q and Q. So the question says it is equal to this. So let's get to work. So the first thing I'll do here is to decompose this into partial fraction. So by decomposing it into partial fraction, I have 1 over Q plus 1 multiplying Q plus 2 multiplying Q plus 3 is equivalent to 1 over 2 multiplying Q plus 1 minus 1 over Q plus 2 plus 1 over 2 multiplying Q plus 3. Okay, so I'm gonna insert it here. I have that S is equivalent to our sum, which is sum to infinity of Q starting from 0. So I have 16 to the power of minus Q multiplying the binomial 2Q and Q. So now I will introduce the partial fraction. Okay, I have 1 over 2 multiplying Q plus 1 minus 1 over Q plus 2 plus 1 over Q plus 3. Alright, so let me take this part off. Okay, now let me wipe this off. Alright, please note something down. 1 over Q plus, let's say n plus 1 is equivalent to the integral from 0 to 1 of x to the power of Q plus n dx. So let's apply it in our sum. I have that S is equivalent to the sum to infinity of Q starting from 0 then our binomial of 2Q and Q, 16 to the power of minus Q. Then the remaining element of this will come in. So I have the integral from 0 to 1. Now in the first case I have Q plus 1. Then if you refer it to this other one, you find out that n is 0. So I'll just have half of x to the power of Q. Okay, then the second one has Q plus 2, and if you refer it to this place, you find out that n is equal to 1. So here I'll also have minus x to the power of Q plus 1. And comparing this other one, you find out that n is equal to 2. So I have, this is half of x to the power of Q plus 2. Since in this place n plus 1 represents 3, so that's why I have 2 over here. So we have our dx. Okay, so the next one we have s is equal to the integral from 0 to 1 of the sum to infinity of q starting from 0. Introducing our binomial. Now we have 16 to the power of minus q, or rather I can still write 1 over 16 to the power of q. Alright, then introducing the remaining parts, I have half of. Now if you watch it, there is x to the power of q everywhere, so I can easily extract them from this top. So extracting the x to the power of q and inserting it here, I have x to the power of q multiplying the bracket containing 1 over 2 minus x plus, here I have plus half of x squared dx. Alright, so here both of them have the same power, so I can just unite them. Let me write x here. Alright, perfect. Now note that the sum to infinity of m starting from 0 of a binomial 2m and m multiplying x to the power of m is equivalent to 1 over square root of 1 minus 4x. So in our case here, if we relate it with this, we find out that we have x over 16. So instead of x now, I'll replace this with x over 16. Sorry. And this other part with x over 16. Proceeding, I have that this is 1 over square root of 1 minus x over 4. Alright, so I have the x is equal, taking this part off, I have x is equal to the integral from 0 to 1. Now let me insert this. I have 1 over the square root of 1 minus x over 4. Alright, so it's going to multiply this remaining part, which is half minus, minus x plus half of x squared. So let me take this part off so that I'll be left with. In order not to make this video too long, I'm going to cut it short here. You can check out my next YouTube video on where I explain how this integral can be evaluated. Meanwhile, don't forget to show me love by liking this video. See you next time.